Hello everyone. Today we are going to solve the sixth problem of AtCoder Beginner Contest 338, which is negative traveling salesman. So for solving this problem, two similar problems or two well-known problems will be required. So I will suggest you to look at those two algorithms. You can say one is certainly traveling salesman problem, and the second one is Floyd-Warshall algorithm. So what traveling salesman problem is and what Floyd-Warshall problem is, let me give you some overview. So for traveling salesman problem, we are given n vertices, and we have to find one path which is covering all those n vertices, and we have to find the minimum possible path. So we have to find minimum possible path in traveling salesman problem, while going through every vertex at least once. That's what traveling salesman problem is. So find a path going to n vertices at least once is called traveling salesman problem. And what is Floyd-Warshall problem? Floyd-Warshall problem is nothing but finding all pair shortest path. All pair shortest path is Floyd-Warshall problem. So these two problems are required. You can look at the what these two algorithms are. I will provide the link of the code in the description box also, the GFG link. Now let's look at the problem. So the problem is nothing but a variation of the traveling salesman problem. We are given a weighted simple directed graph with n vertices and m edges, which vertices are numbered from 1 to n. The ith edge has a weight of wi, extends from ui to vi, and we have to find the traveling salesman problem's path minimum weight, but here the condition is that weight could be negative. So in the traveling salesman problem, all the weights are positives, because in a real world, when a traveling salesman is moving from one town to another town, the cost will be always positive. That's why traveling salesman problem considers that all weights are positive or greater than equals to 0, you can say. But here the weights could be negative. That's the only difference between traveling salesman problem and this problem, right? And one condition is given to us is that there will be no negative weight cycles. There will be no negative weight cycles. So let's say why this condition is important. Let's say we have found that there is a negative weight cycle considering these three nodes 1 2 3. Then we'll just iterate over this loop again and again, infinite time. We'll be having negative infinity cost. That's why negative weight cycle is not allowed. Okay, I hope you get it. So this condition is important. And the how now, let's look at the constraints for observation. The first observation is that n is less than equals to 20. That means order of 2 to the power n is allowed, order of 2 to the power n into n is also allowed, and order of 2 to the power n into n squared is also allowed. So our overall time complexity could be like order of 2 to the power n into n square. Okay, now what is the time complexity of traveling salesman problem? Look at that first. The time complexity of traveling salesman problem is also 2 to the power n into n square. So we have to use this. We have to use the algorithm of traveling salesman problem. Just we have to optimize it, or we have to just modify it, you can say. Okay, we don't have to optimize it, we just have to modify it. So what this traveling salesman algorithm does, okay, so this algorithm does is that we will be having some mask or bit mask, you can say, bit mask containing all the vertices which are visited. So 1 means that the ith node is 1 means that ith vertex is visited, and ith node is 0 means that it is not visited. And we'll be having also one node I, which is denoting that what is the current node we are at. Okay, so one condition here is that mask and 2 to the power I, you can say mask and 2 to the power I should be always positive, right? That's the condition for any node mask comma I. Now what could be the transitions? Say let's say we are at some node mask comma I in the recursion state. We are at some node mask comma I in our recursion state. Let me call it as m. Okay, first all. Now we can move to any node j. We can move to any node j. So our second condition will be rec of m plus 2 to the power j comma j, because we are moving from I to j, and the cost between w of I to j will be added. Okay, the cost between w of I to j is added because we are moving from I to j. Now for calculating this wij, we can take help of our Floyd-Warshall algorithm, because Floyd-Warshall all pair shortest path algorithm gives us this w of ij to us in order of n cube. Order of n cube is definitely possible because n is less than equals to 20. So that is our algorithm. But here comes one case. Let's say we are having some mask, let's say where first, second and third all the bits are set. Now let's say there is an negative edge from 2 to 3. Now you can say that we can let's say 111, the bit mask 111 and 2 is given to us. Now you can say that from this we can just take the path from 2 to 3 and directly jump from 111 comma 3. So the recursion state from recursion of m plus 2 to the power j comma j is not exactly m plus 2 to the power j, it is m or 2 to the power j, m bitwise or 2 to the power j. So you are saying this, that m or 2 to the power j comma j is also possible. Then let's say there is an edge from 3 to 2 also, there is an edge from 3 to 2 also. So then negative edge from 3 to 2 also, then there is a loop, right? There is a loop. But let's say 2 to 3 is also a negative edge and 3 to 2 is also a negative edge, then it becomes a negative weight cycle, and the problem statement says that negative weight cycle is not possible. Now I will give you another one cool observation here is that let's say we have some node some bit mask 111 comma I, let's say some mask, let's call it as mask and I. Now you are saying that we are going to same to mask comma k, after that we are going to mask comma k after that. Now let's say before coming to mask comma I, we are at some old mask, or you can say o mask comma j. We are from o mask comma j we have gone to mask comma I, and after that we are going to mask comma k, right? Now there is an observation that instead of going to j comma I to I comma k, we directly go from j to k. We can directly go to j to k, because our Floyd-Warshall algorithm guarantees that if we directly go from J to K, we'll be having the minimum cost, right? We can directly go to J to K with minimum cost. So why we are taking this edge, mask comma I? Why we are taking this edge, mask comma I? We can directly go to J to K, right? So so what I am saying that we can just ignore m or 2 to the power j part. We can directly take m plus 2 to the power j. I hope you get it. So so if j is not set in mask, we'll only be taking that node, right? Now let's look at the code here. So here dp to ij will denote the minimum shortest distance between I and j. It is used for Floyd-Warshall algorithm is used to find the minimum possible path from I to j. And here I am iterating over all the j's, and here we are iterating over all the i's. So we will be going from I to j, we will be going to I to j, and we are checking that j is already present in the mask, and here we are checking that I is already present in the mask, right? So here we are doing dp mask j is if dp mask I is not infinity, dp mask j is equals to minimum of dp mask j comma dp mask I plus dp to I plus 1 j plus 1. Here we are doing one based indexing, that's why we have to take I plus 1 j plus 1 here. And here the OR condition is handled. You can also remove this part because this is not required. Here we are doing the part where j is not present in the mask previously. So the old mask will be mask minus 1 to the 2 to the power j, and the rest of the part dpi 2 I plus 1 j plus 1 will be same. And at the end we are taking where mask is all ones, and we are taking the minimum value of all the ending nodes, right? And if answer is greater than equals to infinity, then we are taking answer is no. I think you will like the video. If you have any doubt in any part of the explanation, you can write in the comment section. I will provide the link of the code in the description box also. If you find this video helpful, please like the video and subscribe to my channel. Thank you.